So we'll start with Faraday's laws of electromagnetism. See, before we start with this topic, there is one more topic which you should be aware of. Okay, so it's more like a prerequisite. So that's magnetic flux. Okay, so magnetic flux. See, magnetic flux is very simple. You guys have already learned it before. See, magnetic flux is basically you have some area. Okay, so in that you take an area vector, and then magnetic field lines are coming. All right, so the total flux which is passing through the area is given by phi is equal to b ds cos theta. See, this is the same as electric flux. Whatever you did in electric flux, the same thing, but we have magnetic flux. Okay, so you have phi is equal to b ds cos theta. Okay, then so once you integrate this, then you'll get the flux through the entire surface. All right, now again two cases. One, the minimum case, when the angle between the area vector and the magnetic field, if it is 90, then you'll get 0 degree, 90 degree, that's basically 0, right? Whenever it's parallel, then the maximum. Okay, because cos 0 becomes 1. All right, now the SI unit for magnetic flux is Weber. All right, so Weber can also be written as Tesla meter square. All right, and the dimension formula for magnetic flux is mL2T minus 2 A minus 1. Okay, so this is the dimension formula, and the Weber is the SI unit. All right, okay, see, now using this flux, see, flux is what? Flux is basically the magnetic field lines passing through the surface, correct? So using this, what Faraday did was he formulated three laws. Okay, three very important laws. Pay attention, it's very important. So the first law of Faraday was, he told that whenever magnetic field is linking with the coil, okay, magnetic field is linking with the coil, as long as change is present, then electric current is induced. Okay, I'll repeat this again. So what Faraday stated was the magnetic field lines linking with the coil, as long as the change is present, electric current is induced. All right, what this statement means is, see, we did three experiments, right? One, there was change in magnetic field, right? So as long as the change exists, there was change in the galvanometer. The second experiment, again, you put the magnet inside, you took the magnet outside, there was change in magnetic field. Third one was you moved the coil, correct? There was change in magnetic field. So for all the three cases, we prove that wherever you have change in magnetic field, current was being induced. So this was the first law. The second law states that the induced EMF is directly proportional to the rate of change of magnetic flux linking with the coil. Okay, now this is very important. I'll repeat this again. The magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux linking with the coil. So see, what we have is, let's say E to be the induced EMF. All right, now the change in magnetic flux, the change will become phi 2 minus phi 1, correct? This is the change. Now whenever we have rate of change, we have to do phi 2 minus phi 1 by t, correct? So we come up with E is proportional to phi 2 minus phi 1 but divided by t. Okay, now to remove the proportionality, we introduce a constant. So by SI unit, you will get the value of minus 1. So E is equal to minus of phi 2 minus phi 1 divided by t. Okay, negative sign, you might be thinking how. Just wait for another 2 more videos, you guys will understand why the negative sign comes. Okay, so as of now, just think that E is equal to minus of phi 2 minus phi 1 by t. Okay, now there is a rate of change, correct? See, rate of change can also be written as d phi by dt. So we say that E is equal to minus d phi by dt. Now if there are n number of turns in the coil, we have E is equal to minus N d phi by dt. So this law is called as Faraday-Lenz's law. Okay, Faraday-Lenz's law. Now this is the second law. Okay, the third law, what it states is the induced EMF exists as long as the relative change exists. Okay, now when we say relative change, that means the coil can move or the magnetic field can move or both of them can move. Understood? So these are the three important laws. So go through the video and see these laws again because these are very important.